professionalvmware.com vBrownbag. We've got a co-host situation going on here tonight. Oops, I don't want to click that yet. Josh Atwell and I will be your hosts with Chris Sears presenting on Docker, and specifically Docker running on top of VMware. We've got a few special show notes tonight. Josh, you want to take these?
Sure, I can do that. First and foremost, I'd like to make sure everybody is aware that the vBrownbag team has paired up with VM Underground. If you've ever been to VMworld, then you're probably familiar with the Community Party as a Service, which happens on Sunday night of the conference. And what we've done this year is we've paired up with them, and in the afternoon, prior to the Solutions Exchange opening up, we're going to be doing what we call opening acts. And in this, we're going to have a series of panel discussions on a variety of topics that will be going on at the CityView Metreon, which is the exact same location as the VM Underground party. So for people interested in going to the VM Underground party, we highly recommend that you come out between, I believe it was 1 and 5 for the opening acts, and people who come out and attend will get early access to the VM Underground party that evening. We also have a list of really awesome sponsors. That's on vmunderground.com, and if you go on there, you can also get the link for registration. On your screen, you'll see that we have a URL that has kind of the introduction for what we're doing, but this is going to be all community-driven. All the sponsors are, just sponsoring to be part of the community. Second on the special notes there, you'll see the Summer Bookapalooza. And what we're doing there is, just like it sounds, we're giving away a ton of VMware and technology-related books coming from Packet Publishing and VMware Press. And several of these, I believe most of these, and then some others, have been authored by vBrownbag crew members such as myself and Jonathan. And we also have some from the likes of Christopher Cusick and some other great notables in the community who have authored some really cool books. So, go ahead and go to the bit.ly link that you see on there. If you're listening at home, it's bit.ly/B00KPOL, and for the Summer Bookapalooza, and that wraps up on Friday, August 1st.
Awesome. And normal show notes for the folks that are listening live or want to catch up with us later on, you can use the vBrownbag hashtag on Twitter. Follow us at vBrownbag or at vBrownbagAMEA and at vBrownbag, LATAM for the Latin America show. We have our bi-weekly Asia Pacific shows that run on Thursdays, our EMEA shows that are running every Tuesday, our Latin America shows that run every Thursday, and of course here our U.S. show that runs every Wednesday. If you can't catch the live show and you want to download the podcast either on iTunes or your favorite podcast app, you can get those at bit.ly/Brownbag iTunes or bit.ly/Brownbag podcast. Your host tonight is Chris Sears. I left Josh off the slide accidentally. My bad, Josh. I think you all know Josh Atwell, though. And with that, I think I'm ready to turn it over to you, Chris, if you are ready.
I sure am. Thanks for the intro. Let's see. Go ahead and get this.
Becoming panelist, or becoming the presenter now.
Perfect.
I see screens.
All right. Let's get this going. Okay. Is that visible there?
It is, yep.
Okay, terrific. Well, guys, thanks for having me on the show. Again, my name is Chris Sears. I'm a systems engineer with the storage company Tintry. I've been doing sort of cloud stuff, virtualization for close to 15 years now, and I've been running a meetup here in the Atlanta area for about 3 years. Really been kind of paying attention to Docker, and for a couple of years now, Docker and some of and its previous incarnations, which we'll talk about in a little bit. Docker's only about a year old itself, but it's really been making significant waves. And earlier this year, I actually submitted a talk to be considered for VMworld, and unfortunately didn't make the cut. But you guys were kind enough to offer me a chance to come and run through some of the material, and so that's what we have tonight. So I wanted to just kind of get started, sort of level setting what we want to talk about tonight. I'll assume that everybody listening is already pretty familiar with VMware, but has pretty much no background with Docker whatsoever. So if you've been using Docker for a while, or you know a lot about Linux containers, this will probably be a lot of review. But I think there should still be some interesting points in here talking about how Docker and VMware may play together in the enterprise, and what the future of Docker in the enterprise may look like. And so, as I mentioned a little bit ago, this was the basis of a talk that I was trying to get into VMworld. Didn't quite make the cut, but I think there's still plenty of people interested, and so hopefully get some good feedback, and maybe I'll make it into to VMworld for next year. So let's look at specifically what I want to hit tonight. We'll look at what Docker is and how it works, and then we'll kind of get into the meat of it, looking at why you would want to combine Docker and a traditional VMware virtualization environment, and exactly what that would look like. And we'll, without giving anything away, the three sort of themes that I wanted to talk about tonight were using Docker and VMware together for security reasons, for cloud mobility reasons and deployment reasons, and sort of enterprise acceptance. And I sort of put that under the umbrella of sneakiness. So if you were in a position of trying to get Docker into an enterprise IT environment that was already standardized on VMware, there's some ways you can do that would make it a little easier, and avoid some of the hurdles that you might otherwise avoid if you're trying to deploy Docker to bare metal. And lastly, we'll kind of wrap up talking about some opportunities and challenges, and then we'll actually jump into a quick demo just to kind of look at what some Docker basics along the way, and we can take questions. Should have plenty of time at the end. Okay, well let's talk about what Docker itself is. And if you're kind of reading Hacker News and looking around at anything related to sort of Linux deployments and sort of cloud trends and how people are packaging applications for cloud deployments, there's a good chance you've run into Docker, at least seen the term, but maybe a little unclear what people are actually talking about when they say Docker. And at this point, there are actually a few different things, so let's kind of run through them. Docker itself is a company that used to be called .cloud. They were a platform as a service provider similar to Heroku, and they actually developed Docker, or technically it was a predecessor to Docker, for their own internal use. And Docker was kind of the layer that made Linux containers convenient for them to deploy, and actually was sort of the basis for their platform as a service offering. There's a bunch of other pieces that were kind of, they created around it, some very interesting stuff, but Docker itself got open sourced, and it just took off in terms of popularity. And they made a decision that, they for whatever reason, saw more future in Docker itself as a technology, and decided to pivot, and the entire focus of the company is now Docker and kind of the ecosystem around Docker. So today, there's actually two different products or kind of services that Docker, the company, makes. One is Docker Engine, and that's and a quick way to describe it, it's an open source tool for packaging and running Linux apps as portable, lightweight containers. And we'll get into more of what I mean by that in a couple slides here. There's also now something called Docker Hub, which is similar conceptually to GitHub. And you can think of it as the back-end cloud service, which is hosted by Docker, the company, and it makes it easy to kind of collaborate on Docker images and Docker-based applications. So you have a similar concept of public and private repos for Docker images, and it kind of adds some team workflow elements to the whole Docker story. So there's more stuff coming out. I think Docker is going to be talking about kind of their commercial offerings here sometime soon. But it's sort of good to keep in mind there are those two elements of Docker, but most of the time when Docker comes up in conversation or in presentations, people are talking about the Docker engine. So that's how we're going to use it going forward in the presentation. In a few places I'll actually call out Docker engine, but for the most part we're talking about the tool that actually allows you to package and manage and work with your applications and these lightweight containers that you're wrapping around them. Okay, so let's kind of dig into the Docker engine technology itself. And since we have a VMware audience, obviously, let's compare Docker to sort of traditional virtual machines. And probably most of us would agree that today in modern enterprises, virtual machines are kind of like the default unit of deployment. In most cases, you have developers or vendors that are delivering applications as one or more virtual machines. That's just kind of the standard today. The sort of thinking behind Docker was, is there a way we could wrap our applications in something that's more lightweight than an entire virtual machine? And this is certainly not a new concept. People have been talking about just enough OS for a long time. There have been different approaches to this. The idea of containers even is not particularly new. Other operating systems have been doing it for a long time. Solaris zones, different AIX implementations. But the idea is that instead of having your application, so in this case, we're looking at a traditional virtual machine deploying two applications on a traditional hypervisor like ESXi. You would have your application, some number of binaries and libraries that would support that application, and then a guest OS. That whole thing, you can see highlighted in orange here, that whole thing gets wrapped up as a virtual machine. So really, at the end of the day, you don't care too much about the guest OS. You really only care about the application. And so what Docker kind of set out to do was simplify the workflow and the process of actually packaging your application, just the application in the binary, and allowing you to get away from managing an entire guest OS sitting under every application that you deploy. So one of the obvious question is, why would you do that? And it really comes down to speed and agility are the big immediate reasons for doing that. So anytime you might have a build process that has to go through and spin up instances of your application, if you could suddenly go from a few minutes to spin up a VM to a few seconds to spinning up a container, that can really have a huge impact on your dev test cycle, on your developer productivity, and the way your development teams work with your operations teams. So that was kind of the vision, and in the enterprise, things, virtual machines really work just fine. For a platform as a service company, which is where Docker sort of originated, it's kind of table stakes that you have some lighter weight way of representing customer applications. And so that's what .cloud set out to create. And here's what they came up with. There's still obviously a physical server. It has a host operating system. It's a Linux host operating system. So really, instead of thinking about there being a hypervisor that runs right on top of the bare metal, you have some traditional Linux operating system, something like Ubuntu or CentOS or RHEL. And there's actually a couple new ones that are designed exclusively for running Docker. Talk about those in just a little bit, but you essentially have a very minimal operating system. Its job is really just to talk to the hardware, very similar to a hypervisor. And then northbound, it allows you to run Docker. And what you do at the application level is that you create Docker images that bundle just your application and the binaries and libraries that are needed to run your app, but you do not actually package an entire guest OS into that image. And what happens is the Docker engine is able to use some Linux container technologies, specifically C groups, namespaces have been in development for probably close to 10 years at this point. They're getting drastically more mature, and initiatives like OpenVZ and Virtuoso from Parallels have been basically building this technology into Linux for the web hosting industry for quite a long time, since basically I began my career in web hosting. So the approach that Docker has taken is not entirely new, but they did it in such a way that really looked at how do we create developer productivity around this workflow, how do we kind of make things modular, so as the Linux container technology matures, we can sort of plug in different ways of doing things, and they looked at the deployment process so that we can do things in a very simple way and then layer on orchestration tools around them. And even though Docker didn't create Linux containers, the Linux containers LXC technology has been around for a while, something about the way Docker implemented it and made it accessible has really taken off. And when developers kind of get in there and start playing around and see how quickly they can spin up Docker containers, run tests, and actually get their applications running without all of the overhead of a traditional VM, it kind of opens up new possibilities. It sometimes means that instead of limiting my integration tests to 10 combinations of different factors that would affect the operating system, I can open it up to 100 or 1,000, and I can still be running my test suite in a reasonable amount of time. So that's kind of the core value proposition of Docker. It gives you something similar to a virtual machine. It creates an isolated runtime environment. It is different than virtualization, traditional server virtualization, in that you don't get a choice of what underlying operating system and the OS kernel your application uses. So in this case, it is limited to Linux. Your application would have to be a Linux-based app and have a Linux-based user land. But what it sees from inside the Docker container is essentially the exact same thing it would see as if it were running on a regular kernel on bare metal. What Docker does under the hood is it actually leverages C groups, which is a technology that originated from Google, and namespaces, Linux kernel namespaces, to create isolation at the kernel level that gives each application, each container, its own private view of the entire system. So that's kind of Docker in a nutshell. The question then is, do you have to make a choice between deploying Docker on bare metal, like I've sort of depicted here, or go the traditional virtualization route like we were looking at here a second ago? What I would actually propose, and that a lot of people have already started doing on Amazon, on DigitalOcean, on other cloud providers, and in their own labs, is that it really could make a lot of sense to take an existing virtualization environment based on VMware or KVM, Hyper-V, and build on top of that, use one of the minimal operating systems that has been designed to run Docker very well, with a very small security footprint, a minimal surface area, and actually just build on the virtualization infrastructure you already have. And there are a number of reasons you would potentially want to do this, and we'll get into some of the specifics, but I just kind of want to step through and explain this picture real quickly before we drill into the details. Essentially, we're still talking about the view of a single physical host, a physical server with something like ESX installed on top of it. And then in this case, we would have two virtual machines running some minimal guest OS, RHEL 7, CentOS 7, Ubuntu, CoreOS is one of the new ones that's being developed specifically for hosting Docker and Linux containers. Any one of those would be an excellent choice for the actual virtual machine guest OS. Those would actually be running the Docker daemon, and then within each of those guest VMs, any number of applications could be running as containers. So this gives you a number of benefits, and I've kind of drawn them out as app A1, app A2, app B1, and app B2. One of the things we'll talk about from the security standpoint is that if you are in an enterprise and all of your applications are from trusted users or departments within your organization, you may be perfectly happy to run all the applications on top of a single Docker host OS. That may not concern you at all. If you are in a situation instead where you have a multi-tenant environment, so you may be hosting applications for different companies or customers. You may have departments or subsidiaries that you're hosting infrastructure for that have different regulatory requirements. The amount of isolation and the security guarantees that Docker provides between two containers is fairly robust, but it is not as strong as the kind of isolation that traditional server virtualization is able to provide. And it also doesn't have the track record. It doesn't have the years of security researchers banging on it that ESX and some of the other more mature hypervisors have had at this point. So one of the points we'll talk about is that it may be worth considering using VMs as a strong security container to isolate tenants in a multi-tenant environment. And then within those VMs, you can use Linux containers through Docker to deploy multiple applications inside that security perimeter. So that's kind of a quick intro to what Docker is. And at this point, let's kind of shift gears and talk about three different reasons, three different themes why you would want to actually combine these two technologies. The first one I want to talk about is security. So I mentioned this previously. It's worth repeating that Docker itself is not a container. It doesn't implement container features itself. It is more of a management, packaging, workflow tool that sits on top of a container implementation. And right now the main implementation is actually based on Linux containers, which are called LXC. And the two kind of key enabling technologies inside of LXC are kernel namespaces and C groups, control groups. Interestingly, Google was sort of famous for saying that they have so much hardware and they want to run so efficiently that they couldn't afford to run their own services using traditional virtualization. And what they decided to do instead was actually use Linux containers. And they did some of the early work and contributed what became the standard Linux feature, cgroups. The other more recent development that really has allowed the isolation and the higher level security for containers is kernel namespaces. And this is essentially a layer on top of the normal Linux kernel structures that allows for segregation in different contexts. So there are actually several different namespaces. There are user namespaces, process namespaces, network namespaces, and it's kind of a complex system. There are ways you can manage it directly with the LXC commands, but what a lot of people have found is that Docker does a good job of abstracting that complexity of LXC, and it gives you a very approachable way to start using Linux containers without really getting into the weeds of how namespaces and control groups work. So that said, there are still some security concerns. We talked about it just a few minutes ago that even though LXC has made some amazing progress over the last few years, it is not as mature as some of the security guarantees provided by traditional hypervisors. And we're mostly speaking about VMware today, but a lot of the same things would apply to a hypervisor like KVM or Xen or Hyper-V. So what's the concern? Well, essentially, if there is a much larger surface area in the Linux kernel for an exploit to come out where something running inside a container could actually escape the isolation enforced by Linux namespaces. There's more of an opportunity for something to be misconfigured and actually have a privilege escalation. Some of the features that would ideally allow for containers to run as non-root users and less privileged accounts, some of that is actually still in development today. A lot of the core security things, the hardest things, sometimes that actually just gets pushed off till later in the project's development, and some of that has happened with LXC. But a lot of the interest in Docker has actually accelerated the LXC features, and a lot of that's being pushed by companies that really want to deploy Docker in production, and they really rely on and they're pushing for higher levels of security enforced by the Linux kernel. So at the moment, if I were betting my business on it, I would not take the current implementation as being so hardened that I could run untrusted code in two different containers on the exact same host. Based on current technologies, VMware, KVM, Hyper-V, any of them would be the basis for providing more secure multi-tenant system to isolate tenants. And then within those tenant environments, it makes absolute sense to use Docker and Linux containers to spin up individual applications, individual containers, or microservices is kind of the prevailing pattern that a lot of people start using once they get into Docker. But still, under that Docker layer, and if anyone were to escape the isolation implemented by Linux containers, as long as they're actually inside a VM, you have those two levels of protection. And based on the current implementations, I think that makes a lot of sense, especially for business users that have multi-tenant environments. Another thing to just kind of mention is that there are still some limitations around kernel resource accounting. So there are some Linux kernel data structures that don't have quotas enforced for them. This is again work that's still going on today to try to close some of these gaps. But theoretically, you could have a denial of service attack in some situations if one container started making calls that exhausted certain kernel resources. Another interesting one that popped up a few months ago was Shocker. It was sort of a proof of concept that sort of showed how if you were to try to run an untrusted container, it could actually expose file data in the host OS in a kind of an unexpected way. So again, not to scare anyone off from it, but it is kind of an evolving situation, and today, if you want the highest level of security, running Docker inside a VM that's providing that higher level of isolation probably makes the most sense. So the next one I wanted to talk about was Docker for mobility. And this is really where you'll see the most business value if you wanted to consider adopting Docker and Linux containers. And what I've personally seen professionally is that VMware is still very dominant, but companies are increasingly exploring other platforms, AWS, Azure, other cloud providers out there. And what some teams sort of get caught up in is that they pick a tool set that is very infrastructure dependent, and sometimes they make investments in tools and procedures that are sort of locked into one provider or one vendor, and if a business decision gets made that actually requires them to shift the environment, the cloud environment or dev environment to something completely different, it can be very disruptive and expensive, and sometimes might require throwing away tools or investing in new tools. And kind of the interesting trend around Docker is that it almost becomes an abstraction layer. So you can run Docker on your Mac or Windows developer laptops. You can run it with something like Fusion or VirtualBox. You can use Vagrant as a popular way to kind of create a little intermediate layer, so that you have something like OS X or Windows as your base OS, and then a minimal Linux environment running in a hypervisor locally, and then that minimal Linux environment is actually what runs Docker, and then you can run your containers inside that environment. That creates a very easy, very approachable developer and QA workflow. And the great thing about it is that Docker images, when you, and we'll walk through this in the demo in just a minute, if you say, I want a new Docker image based on Ubuntu, the latest version of Ubuntu, it will pull that down as a layer, and then any changes you make to that container instance will be sort of kept separately. It's sort of like a differencing disk. And then when you're done with it, if you want to save that, you can commit it, and it will keep track of just the changes that you made to your container instance. And you can push that back to your own public or private repo. Someone from your QA team can pull it down, and if they've already downloaded that Ubuntu base image, they may only need to pull down maybe 10 or 100 megabytes of data that's associated with your application and whatever changes you made, and that push and pull process can be incredibly fast. So we've sort of gone from an environment where if you were using entire VMs to wrap your application, which could be 1, 2, 3, 10 gigabytes sometimes, to an environment where you can be pushing versions of your application around very quickly and easily. That really translates to faster iterations, turning around, getting features to market faster, and a lot of teams are really finding it very attractive. So the idea of Docker for mobility is really catching on, and the kind of the scenario that I typically see playing out is that you'll have distributed development teams using perhaps Mac laptops, using Vagrant. There's a very convenient tool called Boot to Docker, which is available on the Docker website. Has easy links to it and some getting started tutorials. It makes it very simple to download that minimal image and the actual Docker client files, and you can be up and running with VirtualBox under the hood and have a development environment where you can start actually deploying your application, doing some local testing, and then pushing it back up to a repo and sharing your Docker image with other people in your team. Where I kind of see the biggest business value is actually in QA environments where you're actually having to fire up instances of your application as VMs and running a test suite. This, sometimes VM spin up and tear down can be, anywhere from minutes to half an hour. If you have a large data set that you may have to import and go through some setup procedures before you can actually run your integration tests or unit tests. Transitioning from an environment like that to Linux containers can just take an integration process, going through a full regression test can take it down from hours to minutes, and being able to iterate faster and give your QA and development teams quicker feedback can really be invaluable. Kind of the production side of it, and there definitely is a DevOps theme to Docker. It definitely appeals to both and was designed for hybrid teams or teams that were needing to collaborate between development teams and operations teams. But the second piece to it is really being able to deploy applications to production. And this, I really feel this is where Docker differentiates from something like Vagrant. Vagrant's a great tool. I use it personally, but I typically wouldn't use it for production deployments. I really would see it as more of a dev test focused tool. Docker really continues to be part of the equation even into production because it simplifies the rollout process. If you've kind of done things correctly, you've broken your application into the minimal pieces. Docker images are or Docker-based applications are very process-centric. So there's actually some interesting work done where you can actually have socket activation for containers because it's so fast to spin up a container. You can have something like system D that's listening on a particular port, and when a request comes in or a packet comes in, it will actually spin up a container to service that request. And then if there's no more traffic on that, it could actually spin the container down. It's that fast. It's effectively as fast as starting any other process in Linux. And so that level of sort of agility means that you can deploy tens or hundreds of containers on a single operating system. And when you have that sort of flexibility, that a lot of the traditional patterns where you would have an app server and you'd have database processes and app server processes and everything all running together in one OS, you can kind of get away with that or move away from that and actually have containers where just the dependencies for the database or just the dependencies for your Python app server or your Ruby on Rails app or whatever are isolated, so that if you do need to do library upgrades or binary upgrades or patch things, you are only patching the absolute minimum needed to run your application or just that sort of microservice element of your application. And it really leads to better application level security end to end. So if you kind of drink the Docker Kool-Aid and you're able to architect your application in that kind of a pattern, you have a lot of flexibility. So anywhere that Docker can run, you can deploy your applications. So Amazon EC2, Azure, VCHS, Google Compute has done a bunch of really interesting work around containers, and of course your local virtualization environment. So you could run it in your own private cloud just as easily as you could a public cloud. And because you have Docker in there as kind of an abstraction layer, you could, if your boss's boss decides that you're going to switch from AWS to Azure next week, as long as you can run Docker, it's kind of a non-issue. So that's kind of the mobility story. The last piece I wanted to kind of talk about for combining VMware and Docker is sneakiness, and that's sort of the concept is, if you're in an enterprise, I think probably all of us know how political it can be adopting new technologies. A lot of us are in a position where we want to try new stuff, but convincing architects or the gatekeepers of the infrastructure or people in charge of standards can be difficult. And a lot of the sort of long-term thinking around Docker is that you would not need a hypervisor under the hood and a VM wrapper around your Linux containers. But today, I think that would make it would make it a harder sell if you had to go to your operations team or your data center team and say, I know we've standardized on VMware. We've got all these hosts, all these blades that are set up, and we have the deployment process is down. But now I need this whole new environment, and I'm just going to run CoreOS or CentOS 7 or RHEL 7 directly on bare metal, and we're going to have to patch it and manage it completely differently. Can you guys just carve me off this separate environment where I can do all this? I'm sure that would fly in some organizations, but I suspect most of us would have trouble getting that approved, especially if it was something new and kind of unproven. And Docker's it's gaining a lot of mind share among early adopters and startups, but it still has a ways to go in kind of having enterprise name recognition. So if you were in a position where you wanted to try it, you test it out locally and you think it would be a great fit, deploying it on top of VMware really gives you a way to sneak it into an enterprise with the RHEL 7 support that they've just announced, the Red Hat's announced. The timing is actually really good. If you have kind of standardized and Red Hat is kind of the blessed operating system in your organization. Red Hat is just now sort of I don't want to say catching up, but they've kind of gone through all their normal integration and QA process, and now a lot of the underlying technologies for LXC and some of the technologies that Docker depends on are being implemented in Red Hat 7. So you could essentially ask for a Red Hat 7 VM, and if you don't want to tell anybody else what else you're doing with it, you could certainly do so. And once they deliver you that VM, you could sort of start using that Red Hat 7 VM or that CentOS 7 VM or an Ubuntu VM as the basis of your kind of like your own little hypervisor. But instead of deploying VMs on it, you're deploying Docker containers. And you would be able to do some of the same workflow things that we talked about. You could use it for development. You could sort of create your own small platform as a service environment or a large platform as a service environment. You're really only limited by the system resources of the guest VM itself. And you have a lot of the flexibility to move containers around. A lot of the sort of prevailing patterns that you see in container-based infrastructure kind of follows the newer thinking around cloud-based applications. So some of your containers may be stateless, app servers that really don't have any state themselves. and you may have other containers that are stateful, running databases or file services or things that you actually do care about the state. So that's just kind of a quick run through of how you might be able to get Docker into your environment. I have mentioned CoreOS a couple times. That's a very interesting project, and kind of the idea is that if you were to start from scratch on a Linux distribution and you knew the only thing you would ever do with it was to deploy Docker-based containerized applications, and you really needed only a few other advanced pieces of functionality, so namely some orchestration tools for wiring up containers so that your app server containers can talk to your database containers and your web servers. There's some interesting things that the CoreOS team is doing with a tool called etcd, which kind of gives you consistent state information and sort of cluster coordination information across a large number of systems. They have their own tool called Fleet that makes it easier to scale and do configuration and auto discovery for containerized applications. It would be an alternative to something like Red Hat 7 or CentOS 7 or Ubuntu, but they are really doing a lot of interesting things and definitely worth keeping an eye on. The other kind of solution in that same space is a Red Hat effort called Project Atomic, and this is sort of more closely aligned with some of the Fedora projects, and it's taking a similar vision of, if we wanted to modernize OS management and application deployment, and we agree that the future is containerization and pushing everything that we possibly can into containers, keeping the base OS as minimal and lean as possible. What would you need? What additional tools would you want to provide? And Project Atomic has kind of been spun up since just April, I believe, to kind of start working on that vision. So still pretty early for Project Atomic. Some of the early sort of pieces are coming into place with Red Hat 7. CoreOS, not quite ready for production deployments yet, but definitely worth keeping an eye on. And there's a whole ecosystem of tools around Docker that, once you have that sort of base infrastructure in place, you can start playing around with it. You can sort of set up your own internal platform as a service. So anyone who's familiar with Heroku or App Engine kind of knows the productivity benefits of not having to deal with all the lower levels of application deployment. A lot of those same solutions are available based on Docker infrastructure. Just like .cloud built, there have been similar initiatives around creating tools and deployment technologies around Docker. Interestingly, you can actually use different cloud deployment technologies. OpenStack is probably the one people would be most familiar with. And you can actually use Docker as essentially a drop-in replacement for a traditional hypervisor. And you can't run Windows, obviously, but you can spin up compute instances extremely fast because they're all being backed by Docker containers. So that is kind of the quick run-through. Just to recap some of the opportunities and challenges. Docker is a technology that's really moving very fast. It's gaining a lot of traction among startups and companies that have already sort of standardized on Linux for their application environment, that are doing a lot of dev, QA, and operations work where we sort of already have the DevOps collaboration in place, and people are looking to iterate faster and do even more integration testing over a wider number of combinations of test environments and factors that may drive their unit tests and integration tests. And the opportunity to actually do that in a more traditional IT environment that's standardized and very set on VMware or Hyper-V or another server virtualization technology means that you can actually, there's an opportunity for you as someone, an IT person in your organization, to actually introduce Docker in these environments. You don't have to wait for things to mature even further. You can play around with it. You can actually kick the tires and start getting familiar with Docker. It definitely has all of the signs of a technology that will break into the enterprise in the next year or two. And similarly to how, if you think back to when VMware was new, there was a lot of skepticism around how much you could safely virtualize, what the future of it would be. A lot of people said, no, we'll never run any high-value applications in VMware. This is kind of just a toy, and time has proved them wrong. And I would say people who are interested in getting into Docker now and learning Linux containers, there's a similar opportunity out there that if your organization is already very focused on Linux applications and there's value to being able to do deployments and development and operational tasks more quickly, you could be that person that kind of unlocks that value if you're interested in start playing with Docker today. So a couple of the challenges just to be aware of. Like I said, it's moving very fast. They've really tried to stabilize a lot of the APIs and the interfaces that you might need to do work against. The internals are kind of still in flux, and some of the very advanced security features are still being worked out, but it's not too early to start playing around with it and start getting familiar with it. One of the interesting things I'll mention is on the storage level. To date, the primary storage technology that Docker has used for that differencing disk feature has been something called AUFS, and that has not been present in any of the distributions other than Ubuntu, typically. And what Red Hat did was they've actually contributed a couple of new implementations that are based on device mapper. So it actually enables some new scenarios, and it looks like that will make it much more readily available. So you won't actually have to install AUFS and some of the custom kernel changes that went along with it to actually use that differencing disk technology. So that's just an example of some of the new features and new implementations that are coming along in the Docker community. In some organizations, today people are just now getting things closer to 100% virtualized. And, there are some people that are just now saying, fine, I'm finally willing to let, those high-value databases and line of business apps move over to virtualization. And, the prospect of saying, okay, now that we've finished this move, let's start moving things to containers, it could certainly turn some people off. So that's definitely why I recommended taking a sneakier route and find some ways you can add value and introduce it without threatening people. I sort of threw this out there on Twitter, but you may actually hear people saying, what percent containerized are you? And I say that kind of half joking, but if you ask Google, they would say 100% containerized, and that kind of if we've learned anything from sort of the cloud revolution, it's that what the biggest players in the industry are doing today will work its way into the enterprise eventually. And I would say that the reasons Google decided to go with containerization will start to apply more and more to big enterprises, medium-sized enterprises. Another obvious one I've tried to mention a number of times is it is a Linux-only technology today. Parallels Virtuoso is a commercial company behind a lot of the kernel work that's enabled LXC. They have a Windows-based version, but it's I would say don't expect a Windows version of Docker anytime soon. It's really ideal for environments that have already standardized on Linux for application development. The last one I would throw out there, and this may or may not be a concern to you. Docker is all open source, so there's really no threat to the technology going anywhere, but Docker as a business is still a little unclear. It's likely that they will take a similar track as GitHub. GitHub seems to be doing just fine as a company, and the popularity of Docker seems to almost guarantee a good opportunity for Docker, the company, no matter what route they decide to go. But as of today, it's a little unclear how they're actually going to make money going forward. So with that, this was a shot of one of the container technology talks at the OpenStack conference just a couple months ago, and I'll just kind of throw this out there that this was on a Wednesday at about 3 p.m. and there was a cookie truck outside this room, and yet it was standing room only. So a lot of people are paying attention to containers, and I would say there's a good chance it will be revolutionizing application deployment and at least Linux-based application infrastructure over the next year or two. And it's like I said previously, I think it's a great opportunity for some forward-thinking folks in IT teams to actually look at ways they can move their application infrastructure down the road.
Yeah, so I can attest to this photo because I'm actually in the back of the room. You can't see me holding a cookie.
Excellent. Well, I can jump into a quick demo, or if we want to take questions, I'm happy to do either one.
Hey, Chris, I had a question.
Sure.
With CoreOS and Project Atomic being fairly new, you mentioned they may not be quite production ready. Is CentOS 7 or Red Hat 7 or later Ubuntu distributions more production ready for containers right now?
So I would say Ubuntu is probably the most mature at the moment. They've had AUFS support, in the system, in the kernel for quite a while, and that's kind of been the go-to host OS for most people today. If you're in a position where you're deploying to bare metal, you may also be comfortable deploying your own custom Linux kernels. That's definitely not for everyone, but that there are people who have gone that route. So I mean, if there's business value to squeezing the absolute maximum performance out of your hardware, and the thought of having a hypervisor between your application and your hardware, that 5 or 10% overhead bothers you that much, you may be okay, compiling your own custom kernel. But what I'm really excited by is that Red Hat seems to have really embraced Docker. They had a bunch of work around OpenShift, which is their PaaS, and they're actually combining a lot of the technologies they released for OpenShift, specifically Geared D, that does sort of deployment orchestration. And they're folding that in and sort of unbundling it in some ways that's pretty exciting. So I would say keep an eye on RHEL 7 and CentOS 7, but historically Ubuntu has been kind of the go-to guest OS or host OS for production deployments today.
Great, thanks.
You bet.
I've got no other questions right now in the GoToMeeting window or on Twitter, so if you wanted to hop in or if Josh has any questions that you've grabbed.
Sure.
No, not that I've grabbed, but one thing that came up immediate to me as I was looking at, I noted that you had listed and had kind of talked a little bit about it being a little more efficient to install the Docker engine on bare metal. However, my first thought was, especially when you're looking at multi-tenancy, and you had made mention of having a Docker engine installed on a virtual machine, per client, for isolation, that with the virtualized networking capabilities and some of the additional functionality for high availability, and it seems like the business case and the value of virtualizing a Docker engine would be better, unless, of course, the resource requirements were really high. I mean, is it just resource intensive to where it's more efficient on bare metal, or is it, what are the resources like for that?
Sure. So it's really less of a question of the resource overheads for Docker, because those are actually extremely minimal, and it's more just what overheads does your virtualization solution of choice, be it VMware or Hyper-V or KVM, what does that actually introduce? So that's really the delta that you would see, and so in most cases, some benchmarks I've seen, it's in the range of 5 to 10%, and so I would hazard to guess that for enterprise deployments, that's not much to worry about. If you're operating on Google scale, or eBay or Spotify or some of the other big companies that have started talking about using Docker and some of them are using it in production, that 5 to 10% is a big deal. So really, some of the other benefits I didn't mention previously. You can do things like demotion your Docker, your virtualized host OS VMs around to do physical maintenance. If you were deploying on bare metal, kind of the more cloudy approach to something like that would be to say that if you've designed your application right, you should be able to just update your load balancer rules, or take something out of a cluster and then kill all the containers on that particular physical host, do your maintenance, and then bring it back up and restart the containers. A lot of people have not sort of moved from that pets model to the cattle model that works so well for cloud applications. So being able to actually vMotion something over and not have to worry about dynamically changing load balancer rules or database masters can be attractive. Interestingly, there actually is some work on a project called Creo that would actually allow you to do sort of a checkpoint and restore process on a container. It would actually capture all of the state. You'd probably need some kind of shared storage on the back end, but it would allow you to sort of snapshot a container and then stop it on one physical server and actually start it up on another physical server. But that's not quite ready for prime time yet. Okay, well, if there aren't any more questions, I thought we could run through a couple quick examples. So I actually have boot for Docker installed here for OS X. There's also a version available for Windows. And the first thing I want to do is actually show everyone what it would look like kicking off a process and dropping into a container. So you can see right here, I have a very minimal but standard-looking Linux environment. You can see this hex string right here is actually the container ID, and you can really do anything you would normally want to do in a Linux environment. And kind of comparing what a Docker-based platform as a service environment would look like compared to something like App Engine or traditional App Engine. Instead of being able to deploy your applications at the by sending a jar file or a WAR file to some environment that knows how to package and deploy Java apps or Python apps or Rails apps, you're actually kind of working at the abstraction of a Linux userland environment. So anything that you would want to do to package your application, so installing, doing apt get whatever to actually install prerequisites for your application, copying files in, doing anything you would want to do. Let's see, managing users. You can do anything that you would normally do inside an OS. You can do it inside the container. But when you drop out, and I'm back to my my OS X environment, you can actually look at what's running, and you can see that the changes we made to that container are captured right here. And so a couple bits of terminology just to point out. The container we are in, and it has that container ID, and you can kind of think of that as like a VM name. The image is sort of like a VM template. So this was the sort of base template that I used to create that container, and then any changes I created would be kept separate, would be tracked separately from that base image. So if I wanted to commit my changes back, and anyone else on my team who wanted to look at them, if they already had that base image installed, the only bits they would need to pull down are the bits that I changed in that container since instantiating it. The command, in this case, I actually ran the container in interactive mode, and I had to allocate a TTY inside the system, and then that allowed me to run an interactive command. We can also do something non-interactive, so if you're running something like a test suite, you can say and it will run it, and you'll get the output almost like you're just running any kind of command or an SSH command to a remote system. And the great thing is that if there's nothing running, because it's a process-oriented type of virtualization, there's no overhead when everything's shut down. So you don't have an idling OS. There are no extra files hanging around. There's no memory or CPU being used. It's literally, it will run. It'll start up the environment when you give it a process, an entry process. That process can do whatever it wants to do. It can become a daemon. It can start serving requests. And as soon as that base init style process terminates, the whole container shuts down. And in some cases, you can throw it away. In other cases, you may want to save it. But you have complete flexibility over what's going on inside that container. So a couple other things just to show people here. If you wanted to commit an example here, I grabbed this from one of the Docker tutorials. So we could actually take the container that we were just working with and commit it to a Docker Hub repository. And similar to GitHub, we could do something like that, and then it would take that container and all the changes we made, and it would push it up to the repo, and then anybody else could pull it down if we made that a public repo, or if it was internal, you could set it up as a private repo, and only people within your team could actually access it. You can actually drill down into different images that are running, so we can look at or images that you've downloaded. So in this case, I pulled down the latest Ubuntu image, and you can see this is only 200 megabytes, and changes you're making on top of that tend to be even smaller. Another one to be aware of is the inspect command, and if you're needing to know information about what the IP address was, if you're starting up a whole bunch of these, if you're doing certain operations where you need to programmatically capture some information about a container, it's easy to pull this out. This is in a JSON format. And really the design approach that the Docker guys took is that they want to make it sort of align with the Unix philosophy and make it very, very scriptable. Do one thing, do it very well, and make it easy for people to come in with higher levels of orchestration or plugins under the hood that kind of align with the interfaces they've created. And so what you'll see is really a very hackable product when you get into Docker. With that, I think that kind of wraps up the examples I wanted to run through. Any other questions, or did you guys have anything else you wanted to talk about?
There were a few questions that came up. First one from Dan Barr. Is there a on-premise Docker hub, kind of like you can run GitHub behind your firewall? Is there something analogous to that?
There is. You can actually run it. They distribute it as a container. So I, won't speak for the Docker corporate folks too much, but yes, there is. And I believe it's also open source, so you have the flexibility to do all of that, behind your firewall if you want to. So yes, absolutely an option.
Great. Another question from Michael Simcoe. Are there any abilities to replicate or sync containers between multiple servers?
So today I'm not aware of anything. Generally, the approach that people would take is, if they were, if you were trying to move the data around as part of a development process, and we're not talking about production data, you can push and pull that to a repo. But if you were trying to sync data between, like a primary and a DR site, most people would actually use something, a database level replication, MySQL replication or Postgres replication, for example, and actually do it at the app level or the database level. So it wouldn't surprise me if we see some new offerings that are actually Docker aware. But at the moment, the storage piece is one of the most quickly changing and evolving pieces of Docker, and to my knowledge, there isn't any replication options beyond what you could do at just a normal application level.
And I think of it as a little bit different state of mind too, right? I mean, I don't necessarily need to replicate it. I have my container. If I know I want to bring down that server, I think you talked about this before, I would just bring my container up on another system, whether it's a VM or bare metal, right?
Yep, exactly right. And a lot of the mentality is different when you're in this sort of environment where you've got a whole cluster of database instances that are working together. If you get to the point where if you've really moved over to that cattle model, pets versus cattle, if you're doing it right, you can even shoot your database instances in the head, and it will automatically come back up. And a lot of the forward thinking around the Docker ecosystem is looking down the road and seeing how do we make that more achievable. Doing things so that you don't have to hard code references to external dependencies in your containers. Doing service discovery. Doing things like patching and the initial wire up of local and remote ports, so that you can have things talking to each other without knowing up front where they're supposed to be in your local dev environment versus your test environment versus your production environments. So yeah, it definitely is a change in mindset.
Great. And one last one in the little fun one. Can you install Docker or other container solutions inside of a container? So we saw you kind of logged into a container and it looked an awful lot like you're just bouncing around in a Linux shell. Could you put Docker inside of a container?
I believe you can. I think that there's been some active development around that, and it's one of those things where you sort of have the kernel namespaces within namespaces. And I believe it is possible. It's at least something they're doing some testing and ongoing development around. So it's you can definitely do nesting within traditional virtualization, and if you had a compelling reason to, I believe down the road you'll be able to do Docker within Docker.
So if you see your parent namespace and then you kill your parent namespace, I guess your namespace goes away.
Yes, it is a little. Yeah, I haven't tried all the different.
It's like time travel. That was what I was going for.
or Inception. something.
Yeah, exactly.
So I was going to put the Inception challenge out there.
Oh,
I
yeah.
see a Linux VM running on a virtual ESXi host with a container running inside of a container.
No. A Windows 8 machine running VMware Workstation, which is running a copy of Docker Engine, or Linux running Docker Engine with an inception of Docker Engine running. Okay,
VMware Workstation running a.
Yeah, exactly.
Okay, so it's who can get the craziest levels of Inception by tomorrow. I like
That'd
that
be great.
challenge.
Yeah, terrific.
I've got no more questions from the audience.
Great. Well,
anything else?
I was just going to throw out a quick closing comment. I'm going to be at VMworld with the rest of the Tentry crew and work in the booth for quite a bit of it. So I'm happy if anybody has any interest in chatting about this topic further. Come find me. It's definitely kind of a personal area of interest for me. So I hope people find it interesting. And I'm by no means an expert on all this. I just sort of wanted to bring it to the VMware community, and I figured there'd be someone out there who this could really be a key enabling technology for. So hope it resonates, and come find me at VMworld if anybody wants to chat further.
Awesome. Chris, thank you very much for presenting tonight. This was fantastic.
You bet. It was a pleasure, guys.
All right, I'll catch you at VMworld.
Great. Have a good night.
Good night, everyone.